So when you're writing piecewise functions, you want to determine the domain or x's of each piece, and then determine the parent function for each piece, then apply the transformation rules. As needed. Remember, for linear equations, find the slope and the y-intercept. Okay, so in this example, it's can you go backwards? So we'll start with this one. And usually I want to start with the domains. So I know that the x here is at 0, okay? So I know that it's on the left side of 0, so I know that it's x less than 0. Is this circle included? Yes, so I'm going to say x is less than or equal to 0, okay? Let's see if I can draw a line where you can see it here. And then for this line, this is x is greater than 0, but it also goes to this number 3 as well. So x is between 0 and 3, and it doesn't include either one of those, so it's between 0 and 3. And then this one is x is greater than, and I think that one is open. All of these circles are open except for that one. So x is greater than 3, okay? So it's easy to look at the x's because we're just saying, what x value do I have here? Well, I have a 0 value, and I want the left side, so less than. What values do I have here? Well, I have the values from 0 to 3, okay? Because remember, these are our x's. These are our x's. And then this is from 3 to everything else, okay? So then we need to determine what each of these pieces are. Well, I'm going to start with this one because this looks like an easy one. This is a horizontal line, so this is a constant. So what y value do we have here? Well, the y value here is 3. So I know that the y value is 3 here. And so the y value is 3 every time it's 3 or bigger. So that's easy. This is a line, so I just need to know the slope and the y-intercept of this line. Well, the y-intercept is easy. It goes to 1. So I know that this is plus 1. And then I need to figure out what the slope of this line is. Well, I know it goes down to here. So if I go up 1, 2, 3, and over 1, it looks like it has a slope of 3x plus 1. Now, this is the one that's kind of weird for us because it looks like it might be a quadratic upside down. And so this, I'm going to change colors here for you. Let's make it red so you can see it. This is the one that goes in the middle here, and I'm going to do like this and put it out here. It looks like a quadratic turned upside down. So we know when a quadratic is turned upside down, we get negative x squared. Okay, that's the first thing. And then the top of or the bottom of, usually our quadratic goes this way, right? So this point right here is now up here. So that's what makes negative x squared. So this is x squared. This is negative x squared. So when we get this point, this is usually 0, 0. Well, where's this point at now? This point is at 1, 2, 3. And so what do we do with that? We shifted it up 3. So it's at plus 3. And so that's all we do to write a function. We just shift it, figure out the shifts, look at the lines, and then figure out which way it is. Sometimes if we can figure out this part, a lot of times our answers are multiple choice. We can just figure out like where is the equals to in our thing, what numbers are correct, is it linear and quadratic and then horizontal, constant, just figuring out which are the right parent functions is enough to figure out what is the right one for these equations.